Okay, so let's take a look at this one, and I'll also talk about the alternatives on a couple of the others, just so you are aware of what those are. Okay, so first, we're going to do a hypothesis test with alpha equal to 0.02, and we really need to pay attention to our alternate hypothesis because it is going to tell us um, whether or not to do something to this alpha before we look it up. So we believe this population is normally distributed. We know our population standard deviation, it's 20.7. We have a sample mean of 40.4, and we have a small sample size of 16. We want to know the critical value. For this, what we have to realize is since this alternate is a not equal to, there are going to be two rejection regions. So in other words, on the normal curve, and I know my drawing here is not perfect, if we see not equal to, we're going to have a rejection region on the far left, and we're going to have a rejection region on the far right. Now, if this is a less than, then we're just going to have a rejection region on the left, and if it's a greater than, we're going to have a rejection region on the right. But this one, not equal to, will always have two rejection regions. Now, since it has two rejection regions, that means we have to divide this right here by 2, which would be 0.01. And each of these rejection regions has a probability of 0.01. Now, we're just going to look up one of them because since the curve is symmetric, we'll know the other just from knowing one of them. Now, I'm going to, for a moment, get out of the draw, which will make it all go away. Since we have that it is normally distributed and we have the population standard deviation, we can go ahead and use our standard normal distribution. So we're going to go ahead and put the 0.01 that was in my picture a minute ago into Excel. You can figure out, there we go. So I'm going to go equal norm.s.inv, and I want to put the 0.01 that was in that left tail in there. And that gives me negative 2.326. Now, so in my picture that I had drawn, um, the the value on the left would be negative 2.326, and the value on the right would be positive 2.326. So I'll draw that again because unfortunately the draw feature on this thing sort of erases um, the picture every time I get out of it. So let me go back. Let me write that down so I don't lose it. Okay, so I'm going to draw that picture again just so we can understand for the second part of the problem how we determine the answer to those questions. And I know my curve is not perfectly symmetric, but we're just going to imagine that it is. Okay, so this number over here was negative 2.326, and I went ahead and rounded it to 3 decimal places since that's what it asked for the critical value. And I apologize, writing with my mouse is not very perfect. And then we also had a rejection region over here, which is 2.326. Now, rejection regions always comprise tails of the curve. So this rejection region over here, and this is the rejection region over here. So we're going to do our test statistic in the second part right here. And if we get something that is in this region right here, that is, that's less than negative 2.326, or something that is greater than 2.326, this rejection here, we reject the null hypothesis if it's in that rejection region. Okay, so let's go ahead and do the test statistic. So that's like our z-score. We're going to do our sample mean, which is 40.4. And then I'm going to subtract the mean from our hypothesis. That's our population mean. And we'll put that over our standard deviation, 20.7, divided by the square root of the sample size. So the square root of 16. So I'm going to do all of the top and all of the bottom first. So we'll do each of these separately. So on the top, if I put that into my calculator, 40.4 minus 50.7 is negative 10.3. And then on the bottom, 20.7 divided by essentially 4 is 5.175. I have a feeling that we are not going to be in the rejection region, but we'll find out here in a second. So now I'm going to do that final division. Negative 10.3 divided by 5.175 ends up being negative 1.99. All right, so my test statistic is negative 1 point, let's see, round to 3 decimal places. I got negative 1.99034. So it's just going to be negative 1.990. All right, now let's notice that that is not over here to the left of negative 2. It's to the right of negative 2. So that means it's over here in this area. It's not in the rejection region. So the test statistic is not in the critical region. I would answer that. Since it's not in the critical region, we're not going to reject the null. But we always say failed to reject because scientists do not want to say that their hypothesis is wrong. They just want to say it wasn't wrong in this particular situation. So we're going to fail to reject. In other words, we don't have enough evidence yet to show that the alternate hypothesis is true. We just failed to reject. And then let me move down, and actually I think I will have to, oh no, yeah, I'll have to exit the drawing. Let me write it down. We had negative 1.990. So it's going to make all this go away, but that's okay. All right. So we said we fail to reject the null. Never say accept the null. It's always fail to reject the null. Now, if we fail to reject the null, it means there's not enough evidence to support our alternate hypothesis. And we want to find the conclusion down here that goes along with that there is not enough evidence to support our alternate. Now, our alternate was that the mean was not equal to whatever it was. All right, so 50.7. All right, so there is not sufficient evidence to warrant rejection of the claim. No, we didn't reject the claim that the population is not equal to. So there is not sufficient evidence to support the claim that the population is not equal to 50.7. So we did not reject the null, so we can't support the alternate, which would be this one right here. And I'm not going to click that because I actually have the power to override questions. Well, it won't let me change it, but I'll just make sure I don't save. Hopefully that will help you. Now, if this is a less than, it will mean that we would only have, if it was a less than, we'd only have a rejection region to the left, and we would have put all of the 0.02 there. So when we looked it up, we would have looked up just 0.02. Now, alternatively, if it was a greater than, our rejection region would have been over here on the right. So notice sort of with less than and greater than, our rejection region is always on the side that it points to. That's one way of thinking about it. The 0.02 would be over here. Now, the tricky part about the greater than is you've got to realize when you look things up using Excel or even using your chart that you get the probability to the left. So really, if we subtract 0.02 from 1, this probability over here on the left is 0.98. And that would be the probability that we would need to look up in order to get our critical value over here. Okay, and hopefully that will help you through these problems. If not, let me know.